One of the biggest questions that psychology asks as a field is who we are more because of nature or because of nurture? And so when we talk about intelligence, this is a perfect opportunity for us to ask, is our IQ score more because of our nature or because of our nurture? And if it's both, what's the more dominant contributor? Is it our genetics, our genes, or is it our environment that we were raised in? And so this is a tough thing for psychologists to study because it involves isolating either your genetics and changing the environment or isolating your environment and changing the genetics. So we could keep someone's environment the same and change their genetics, which could be unethical because you're giving someone bad genetic code, or you can keep their genes all the same, but you can change their home environment, some really great home environments, or give them a really bad home environment. But to do this on people is unethical because you could provide them with negative experiences, and it wouldn't fit those 5 ethical principles that we learned about at the beginning of the year. So the good thing, though, is that nature has provided us a way of studying this while being completely ethical, and that is with twin studies. And so before we talk about how twin studies can contribute to us knowing if intelligence is nature or nurture, we have to understand the difference between monozygotic twins and dizygotic twins. So a monozygotic twin is an identical twin, one egg, mono. And so it's one egg, one sperm, and then after it's fertilized, it splits into 2. So you have 2 people with the exact same genetic code, which is why identical twins have to be the same sex. They can't be different because they would have different genes. And then a dizygotic twin is a fraternal twin. 2 separate eggs, 2 separate sperm, 2 separate people with 2 separate genomes in the womb. It'd be the same thing as if you and your sibling were just born at the same time. No more similar than that. So using twins allows scientists to isolate these variables. And so you can see that they will compare identical twins reared together, identical twins reared apart, fraternal twins reared together, siblings reared together, and then unrelated individuals reared together. And then they will look at the correlation of their intelligence scores. And so if you remember, the closer you are to 1 or -1, the stronger the correlation. The closer to 0, the less of a correlation, the weaker the correlation that there is. And so you can see with identical twins, so same genes reared together, same environment, they have it's almost as if the same person is taking the intelligence test twice. It's a very, very high correlation, almost to 0.9. But then you can see that identical twins reared apart have a slightly smaller correlation or a slightly weaker correlation coefficient. So this proves that there is some impact of environment on your intelligence because these people have the same genetic code, but we altered their environment and they had a weaker correlation coefficient. But then we look at fraternal twins reared together. So this is just like siblings, same environment, but different genetic code, and they have a lower correlation than an identical twin reared apart. And so because identical twins, same genome reared apart, have stronger correlation than fraternal twins, different genome reared together, we still know that genetics must be a part of it as well. And so the question is, which is more dominant? Is it the nature or is it the nurture? So let's first start by looking at the genetic influences, the nature influences on intelligence. So this is evidence that we have that genetics play a big role in your IQ score. If you look at here, this light blue, this is children and their birth parents, the correlation between their IQ scores when they're 3 years old. And then you jump over here to when they're 16 and you can see that it goes up dramatically. So they have similar genetics because it's their birth parents. Then you look at adopted children and their birth parents at 3 years of age, and then compare it to 16 years of age, and that skyrockets as well. So the adopted children are becoming more like their birth parents as they age, not like their adoptive parents. This last column here shows adoptive children and their adoptive parents, and you can see as they get older, they become less like their adoptive parents in terms of their intelligence. So correlations between adoptive children and their biological parents increase with time, not their adoptive parents, but their biological parents. So this shows us that there's something very strong about genetics when you're looking at someone's IQ score. When we talk about genetics, this also brings up a term called heritability. And heritability is the extent to which a variation among individuals can be attributed to genes. And this accounts for any trait, including intelligence. But with intelligence, we found that heritability is about 50 to 60%. So what does this mean? Well, first of all, let's talk about what this doesn't mean. This does not mean that your intelligence is 50 to 60% genetic. It means that when we're looking between groups of people, we can say that the difference in their intelligence is between 50 and 60% due to genetics. We can never say that you as an individual have 50 or 60% of your intelligence from your genes. So for example, we know that the heritability of how tall you are, your height, is 90%. So if you have a woman who is 60 inches tall, she can't claim that 54 inches of her height are due to her genetics and 6 are due to her environment. We'd never know that for sure for an actual individual. But what we can decide and what we can show for heritability is among groups of people. So let me give you another example because I know this term is kind of complicated. Mark Twain actually joked about this, but he said, well, what would happen if we took boys and we just raised them in barrels until they were 12 years old and then gave them an IQ test? Okay, so we're completely controlling for their environment. It's all the same. And then these are the IQ scores that we get, 68, 65, 40, and 50. Well, why do they have different IQ scores? Is it due to their environment? No, because their environment is all the same. So that must mean that any difference that happens in their IQ score while they're in these barrels is due to heritability. So in this case, because their environment is very same, heritability is 100%. But in real life, we can never control for environment so closely to where we can get 100% heritability on intelligence. So we say that intelligence is about 50 to 60% due to heritability. So let's use this as another example. Say we take a packet of sunflower seeds and we raise them, we plant them in 2 different pots and we give those pots 2 different environments. We have one that has really poor soil and one that has really fertile soil. Well, if we're comparing these flowers from the fertile soil to the poor soil, it would be really difficult to tell what percent of their height is heritable because they had so vastly different environments while they were growing. But if we look at this pot of fertile soil, we can tell that this flower is taller than this flower. Well, since they had the exact same environment, we can say that their heritability is pretty high for how tall they are. Over here, same thing. This flower compared to this flower is probably taller due to genetics because they have the same environment. So heritability is high within the group that has the same environment, but when you compare group to group, heritability is lower, or we're not able to tell exactly what the heritability is because the variations in environment are so different. So a practice here, if environments become more equal, the heritability of intelligence would either increase, decrease, or be unchanged. What do you think the answer is? And the answer is that it would increase because if we can control for environments, we know that the only differing factor would be the genetic on intelligence. Another practice, in a prosperous country called X, everyone eats all they want. In a country called Y, the rich are fed well, but the semi-starved poor are often thin. In which country will the heritability of body weight be greater? And the answer is country X because the environment is the same. It is more similar than in country Y. The more different environments you have, the lower the heritability can be for a group. And remember, heritability is only when you're comparing groups of people to each other. It can never apply for just individuals. So let's finish off by talking about the nurture influences on intelligence, the environmental influences. And we talked about this some in class today, but neglect is probably the biggest influencer on intelligence from the environmental side. So this could be social isolation, malnutrition, lack of skin-to-skin contact or being held by an adult. And we gave the example of Romanian orphanages, how there's so many children and not enough adults to take care of them. And so most of them are developmentally delayed because they miss those critical components during what we call their critical period of development. Once you pass over that period, it doesn't matter how much you make up of that social connectivity, the damage is done, it's too late. Another impact from the nurture side is school. We know that IQ scores drop during the summer when children are not in school, so that has proven to be an environmental influence. We know that if your birthday is just after the cutoff for kindergarten, that you score lower on intelligence scores than you do if your birthday is just before the cutoff, so you get to be older in your grade, so you have a higher intelligence score based on what grade that you are put in. We also know that so people who are in poverty, who aren't getting the right nutrition, the right contact that they need from their families, probably because parents are both working most of the time. They struggle in school. So what the government has done was created a program called Head Start, which is like a preschool program where parents can send their children to receive mental stimulation in schooling. And what they found is that Head Start is increasing children's intelligence scores, their achievement on tests. It's lessening the fact that they have to repeat grades when they get older. And so schooling has a big influence on intelligence as well. So does this answer the question, is it nature or nurture? No, not really. It's really a combination of both. We do know that, again, heritability is 50 to 60% of your IQ score, but we can never just look at you and say you're 90% genetics and you're 10% environment, or maybe it's flip-flopped, you're 10% genetics and 90% environment. We'd never know that for sure. But I love this quote from psychologist Charles Brewer, who says, heredity deals the cards, but environment plays the hand. So the key thing to remember is that it is both nature and nurture. It's just really difficult to tell for an individual how much of each is which. So I'll see you guys tomorrow in class.